Yeah, actually, do you mind if we start with the recitation slides?
Oh, yeah, let's do
Like at
that.
the very last page where all the
Yes.
formulas are listed.
Yeah, let me get out of this. All right. So down all the way here at the bottom. So the summary
Mhm.
slide here. Okay.
Yep. So I understand how to do absolute fitness, but I don't understand the equation for relative fitness. I know in none of the examples we have had to calculate relative fitness, I think.
hmm
But if I were to, how
So,
would I do that?
right, right. So the way TA Mario talks about it in his video, he says that like normally you're given the relative fitness, but if you did have to like actually calculate this, also Kelsey or Jeanette, let me know if I'm wrong, but the highest absolute fitness that you find from up here out of the three different, genotypes, that is set to one. And then you just find like the ratio of the absolute fitness for the other two genotypes to the highest absolute fitness.
But usually it's given, right? I don't have to worry too much about it for the
Yeah,
exam.
I mean, to my knowledge, you're going to be given that.
Okay, that's good to know.
Yeah,
All right. And for down there of our allele frequencies, I don't understand the top portion. Like what's happening there?
I see. So this just seems like another way for you to actually find the predicted allele frequencies.
Mhm.
Um, so you would just find, I think you would just like kind of plug and chug this equation where you have, p squared, which you'll probably be given that, and then the all of these other variables you should be able to get
Uh,
from these previous equations as well.
okay, but if the bottom one, that we can also use that, right?
I don't know when you would use this, if I'm being honest. Um,
Yeah, that's another thing where I'm getting confused.
right. Yeah, I don't know why you would use this maybe over other ones. Maybe just it depends on what the question gives you or like what
So
information
maybe
the
we can
question.
jump to problem six now, because that's where I was struggling a little bit.
I see. I'm just gonna take one more quick look at this.
Okay, okay.
Kelsey or Jeanette, do you know if they have to use these equations? I guess like on the exam would be like the main part.
Generally, I think the like solving for Q tends to be easier than solving for P, but once you've got that, then sometimes, yeah, you do have to kind of like plug it in a little differently.
Gotcha.
I think that's basically just showing the opposite of the square root of two or square root of Q.
Yeah.
That makes sense. So I don't think that bottom one we've used much, if I remember correctly.
For the bottom one, I know we have used it a bunch while calculating regular P and Q, like not
Yeah.
hmm
fitness problems, but the
Yeah,
regular.
Yeah, the fitness problems, they tend to give you more information just because it's otherwise you're going to end up spending like half an hour just trying to work on one problem.
Yeah.
That for the exams at least. For the recitations, they don't seem to mind giving you half an hour long problems.
Okay. Yeah, maybe we can jump to problem six.
See problem six. Okay. So calculate the mean fitness for the post-selection population.
Yep, so
Okay.
we're given the relative fitness,
hmm
which your W big T, W big T little t, and so on. I
hmm
get that part, and then the formula would be P squared W T big T, and then 2PQ W big T little t, and so on, right?
Okay.
So I
Okay.
used that. I
Yes.
got that from the recitation slides.
Okay.
And then I end up with 0.519.
Okay. So that answer is a little different than the key.
Mm,
Um, let's see here. trying to think of the best way to show how to do this question. It'd be nice to be able to reference the actual equations too. Let me see
But
here.
like that is the equation though, right? For
That sounded correct. Like, yeah, like one of the main ways to do it. And let me see here. So I'm just pulling up the equation sheet on another page again.
okay.
Okay, so when it comes to the mean fitness, yeah, or could you say the equation that you used again?
Yes. So I'll
Okay,
tell you exactly what I have. I
perfect.
have P square
Uh-huh.
W big T
Okay.
plus 2PQ
Mm-hmm.
W big T
Little t, yeah.
plus Q square W little t.
Yes, that sounds perfect.
And then for maybe I just did something with the calculations.
Let
I
me see
don't
a
know.
post-selection. And you used all of this from the post-selection population, like you use these values?
Exactly. The WTT, I
Uh-huh.
use these values, zero point 0.7, 0.9, zero point 0.4.
Okay.
And then for P square, Q square, and 2PQ, I use the top numbers.
I see.
Because we
Okay.
are given the genotype frequencies, right? So these are P square, 2PQ, and Q square that's given.
Yes. Yes. That's right. So what Lakshmi just put in the chat is pretty much exactly like
Wait,
the
that's what I have,
let's see
but
it's
the middle part, the 2PQ, is
mm-hmm.
what I have different. So the genotype frequency for big T, little t is given as 0.50.
Mm-hmm.
Isn't 0.50 my 2PQ? Like, why would I have two 0.5s?
I see what you're saying. PQ, 2PQ.
You got to find the P and Q with the first three from the genotypic frequencies. So that's why you
But
have zero point
but
0.5.
why though? Because
I think it comes out the same, guys. Few
because
times
when the genotype frequency is given, that is my P square, Q square, and 2PQ,
Yeah,
right?
that's 2PQ. That's correct. Even if you use it as a 0.50, then you have to multiply it with zero point 0.9. Did you do that?
Exactly. Yeah,
yeah,
I
so
did.
it's the same because 2 times 0.5 times 0.5 is zero point 0.5.
So
Okay, but I did use a calculator too, so I got 0.519.
I'm not sure how 2 times 0.5 is zero point 0.5. Yeah, it should
Oh,
come up to zero
geez.
point 0.5.
Oh wait.
And then
No,
that times zero
because
point 0.9.
sorry, the big T
Mm-hmm.
is 0.25, right? So
Yes.
that's my P squared.
Mm-hmm.
Oh, you know what I did? I squared 0.25.
Oh, okay. All right.
But that is my P, so that's just 0.25. Okay. Oh my gosh.
Correct. Yes. Yes. The P squared is just
That's
0.25. Okay. I'm
ridiculous.
glad
Oh
that you
my
found that because I was
gosh.
trying to follow along and I was just getting lost.
I am so sorry I confused you all.
That's okay.
Oh, you're fine, don't worry.
Okay.
The decimals confuse me like really badly sometimes.
They
I get
do.
them, yeah. It's just something about having them written that way just drives me nuts.
Yeah, because when Lakshmi put 0.5 squared, I was like, why do I have 0.25? And I was just squaring that. So this really helped me. Thank you.
Okay. Yeah, I mean, these equations are easy to just, plug everything in hypothetically, but man, trying to keep all of these, variables in check is tough.
Yeah. So for the next part though, so if I have the right mean relative fitness, then
Okay.
I know how to do P squared a prime, 2PQ prime, and Q square prime.
Correct.
But after
Correct.
I have those three values, what equation do I use to get P prime and Q prime?
So P prime, I would just use one of the equations that you have on that summary slide.
Okay,
Um,
so I was trying to use the frequency of p squared plus half of 2pq.
okay.
Should I just use that?
Plus half 2pq. Yeah, you could use that one. And then I would also use the other equation just to check.
Do you mind explaining to me the other equation? I feel like I don't understand that equation.
Yes, so explaining it, I'm not sure how they get this equation now that I'm looking at it. But
Yeah, I
let me see here. You should be able to get, oh, I see here. I see what you're asking now. PQ. Let's see. Sorry, I'm not too familiar with these equations. So it looks like, never mind. Actually, you can use that bottom equation.
I
That's what,
can.
yes, that's what's
Okay.
actually used in our
Because the top
key, it
one is
looks
not
like.
making sense because what's
And
PW big A? Like, when
PW
we
big A.
have
See, look,
that.
that's the confusing part to me too, and that's why I'm just looking at the longer version right after that. We have the P squared W big A plus PQ W big A little a. The PQ part is throwing me in for a loop a little bit though.
Yeah, I just don't understand it.
You are going to multiply those P and Q because of the heterozygous ones. That's why.
Okay,
That
so it was so the PQW big A represents the homozygous dominant, and
heterozygous
then
dominant. And
okay.
you have that for both P prime and Q prime. So because we are taking into consideration the dominant ones in the heterozygous one and
Hmm.
for the recessive ones in the heterozygous again. So that's why we are taking care of that part. That PQ is because you're dividing that 2PQ WA heterozygous by 2 because you're only taking half of that, right? That's why.
Right. Okay. I see what you're saying. Yeah, and then to calculate P and Q, you could just get that from the information that's given in the question.
Yeah. Yeah.
But we can always use the second equation, right? That's at the bottom.
Yes, honestly, the second equation seems a bit easier just because if
I
you
just
already
I loved that equation from before when we were doing just P and Q calculations.
right,
So I'm assuming that I can just use the same here for fitness.
it appears that you can. I would just recommend, you know, just recommend using both equations just to double check your answer. But yeah, you
Wait,
should be able to
Lakshmi,
get.
which equation did you use to calculate?
Actually, for problem 7, right?
Yes.
Actually, I stumbled too. So then Luke helped me because I took the wrong equation, but the actual equation is the P prime equals P square times WAA plus 2PQ WAA over 2. Then you divide the whole thing by W mean.
Yeah, yeah. So it's pretty much the same thing that you get. So I guess they did use the top equation. Sorry, I'm looking at the key right now, and both equations look so similar.
Hmm. So in the key, you have the top equation.
Yes,
But in these equations, we have to memorize, right? For example, this one.
you will.
I it's on to be on the safer side. I think we should memorize everything. If we get it, it's a pot. I mean jackpot. That's it.
Right, you're
That's
right.
true. That's true. These are tough equations, though. I will say that you'll probably have to know these top few like better. Well, actually, pretty much all of the other equations you'll probably want to know for the exam. The allele frequencies, though, those might be helpful tools to have on the exam. And then, Liana, after you do the question, feel free to send me your work and then I can double check it.
Okay, sounds good because now that I have the right mean relative fitness, I'm gonna have to
Hmm.
do the rest of the calculations again.
Okay, that sounds good. Yeah, just let me know what you end up getting because I think if you use either of these equations, you might be able to get the right answer.
Okay.
Yeah, because you should have all the variables that you need. Yeah. Good questions though. Yeah, some of these are weird.
Okay, and then for 11 and 12, I did some calculations and would love to double check.
Yeah, let's check them out. Okay, 11. Awesome. Okay, so what did you get for W
For the
big A, big
first
A?
one, I
Uh-huh.
got 4.
All right. You're on the
And
right
then the
track for that.
second,
Yeah.
okay, awesome.
Yeah.
And the
Sorry.
second one, I got 3.5.
Okay, cool.
And
Yeah.
then the last one was 2.5.
Awesome. So does that make these questions make sense overall?
Yeah, yeah. So this
Okay.
formula was very easy. You just do
Yeah.
survivors over the original times the average offspring
Yeah.
numbers, right? Yep.
Exactly. And it helps
And
that
everything was
everything's
given, so
5.
that was
Yeah.
very easy.
Okay, awesome. Yeah, equations like this, I feel like it's a lot easier to actually plug things into the equation, but yeah, some of those other ones are kind of a beast.
Yeah,
Okay.
and then for 12, so I was a little thrown off by it says recessive, but the C's are big C's, right?
Hmm.
So I wasn't sure
Yeah,
what's up with
I
that.
would just treat the big C's as
Little
recessive.
C's,
Yeah,
right?
yeah, so
Okay,
big C's are
okay.
Q, I guess. Yeah.
Okay. Yeah. So the Q score is given, which is zero point 0.7. And then we have relative fitness, which is W little c, which is 1. And then
Correct.
the mean is also given, which is zero point
Point
0.8.
8, correct.
So I did the frequency for Q prime
Hmm.
would be Q squared times W little c over mean W.
Correct. Yeah, that's right.
And then I ended up with 0.875.
Yes. Okay. Yeah, both of
Okay.
those sound like you're on the right track for that one.
Okay. And then let's see.
Okay.
For looking at the table at question 10,
Hmm.
we see we're looking at the change of the frequencies in the second generation, right? Or like the expected generation.
Right.
So
Yes.
the first one we see it's decreasing a little bit.
Hmm.
Second one also decreasing. Third one seems to be increasing.
Right.
That would mean that that trait is being favored by natural selection.
Right. Yeah,
Okay.
because I mean, similar to what Tia Mario had in his video, you're seeing that this, I'm guessing at N2 is the recessive allele. You're seeing that the homozygous recessive is
Mm-hmm.
actually giving some sort of um strength, in the for the organisms in their environment. Just like the color of the insects in Tia Mario's video. It's kind of the same
Yeah.
thing here with the long and short neck.
I guess that kind of is related to question 8 and
Hmm.
9, I mean. So question 8, I have the W little t is the smallest number.
Okay. Okay. You said
And then
little t?
yeah.
Okay. Okay.
And then because I thought it has the smallest number that it might eliminate in the future. That's what I was thinking, but I don't know how to go about this.
I see. Will not eventually. So you're saying that the allele little t will be eliminated.
Yeah.
Right. Okay. So
Oh, is that
yeah.
not what the question is asking?
No, no, no. So it's
Will
asking allele t will not eventually be eliminated.
Oh, that would be false because I think it will
Right.
be eliminated.
Right.
Okay.
Okay. Yeah, all of that looks like you're on the right track as well. So then which one did you have for the largest and middle for 8?
Oh, yeah. So largest, I had the heterozygous big T little t,
Okay.
and then the dominant one was the middle one.
Cool. Yeah, this is kind of a cool way to look at this type of stuff.
Yeah.
Um,
Since you guys are going to be hanging out, maybe I'll just try to resolve the 6 and 7 and then get
okay.
back to you.
Yeah. Yeah, that sounds great.
Okay. Okay, perfect.
Yeah. Yeah, we'll be here for the whole hour. So,
All right, perfect. I might just stay online, do it myself, and then I'll get back to you.
okay, that sounds great.
Perfect. Thank you.
Yeah, yeah, of course.
I got 0.725 for number
Let's,
6.
and that was for question 6.
Yeah.
Question 6, you got 0.25?
No, 725.
Oh, 7.2. Okay, right. Okay, that sounds good.
And then I tried to calculate P prime using 2 different formulas,
Okay.
and then I got 2 different answers.
Gotcha. Okay, so what did you get for that? The
So I
harder
used
topic one.
the p squared plus half 2pq formula and I got 0.55.
It's half 2PQ. Okay.
And then the crazy formula, the longer one, I used that one and I got, what did I get? 0.627.
Okay, gotcha. So for the bottom equation, you got 0.55. What was the
Yeah.
thousandth place? Um,
Oh,
yeah, I think the question
so,
says use 3 decimals. I don't know if you wanted to calculate, but
okay, let me
yeah.
just quickly do it again. I
Okay,
have
that sounds good.
0.241 plus, let's see. I got 5515.
Okay, perfect. So that would round to 552.
Oh, right, because we have the 5 at the fourth place. Yep.
Okay, perfect. So that one got you like on the right track there. The
Okay.
top equation though, yeah, that one gave you a
S-
slightly different answer.
Yeah, so what I have is I have 0.25 times zero point 0.7
Okay.
plus I have half of 2pq, right? It's only pq.
Yes, yeah, you could do half of 2PQ.
So that's
So
what I did, half. I have 0.3105, which is half.
where did you
Because for my 2pq prime, I have 0.621.
okay. I see. So this is for your bottom equation.
Yes. No, sorry, the top one.
Okay, so the PQ, it's just the PQ that's given to you. So it'd be the 2PQ, that's the
Oh, it's not the prime.
correct. Yes.
Oh,
So that
that's
would just
right.
be the point 0.5 up here.
Oh, yeah, let me go back to the formula real
Gotcha.
quick.
Yeah, so that'll be 1/2 times point 0.5
Oh, for these
there.
formulas, you just use the regular PQ, not the prime. That's
Yes.
right.
So that's what's kind of nice about
Okay.
this top formula is that you don't really have to worry
Hmm.
about the prime there or pretty much
Okay,
anywhere.
I
Yeah.
see.
Yeah, you're not working
So
with
in that
any
case, I'm sure
expected.
I would
Yeah.
get the same answer. I see.
Gotcha.
Perfect. I think that's all the questions I had. I'll double check.
Awesome. Yeah, but the 0.552 is on the right track. Yeah.
Okay, I definitely feel better.
Okay, that's good.
Thank you. Yeah.
Yeah, of course. Like I said, using both equations will help you check your work in case like a question like this comes up on the exam. So
Mhm.
that might be the benefit of memorizing both equations, but one or the other should be able to get you the right answer. You just need the prime values in the second simpler equation.
Got it. And just a quick question. Since we have the p square prime already, we
hmm
calculated that.
hmm
Could I just square root that? If it was
That
an easy number. Just
that's a good
curious.
that's a good question. Are you able to, so what was the p squared prime number that you had for
I
the
got 0.241.
241 and then take the square root of that?
I didn't do that.
Okay, because
But I was
honestly,
just
that
curious if I could.
yeah, because that
Let's see.
241, yeah, if you square root 0.241, that might give you 0.552.
Two,
I was
four,
thinking about that as well,
one.
actually.
No, you
Mm,
actually get 0.491.
Okay, so I guess yeah, you can't then.
Yeah, I guess it's because of the square root. I guess the decimals are a little bit off.
Possibly. And it seems like the predicted frequencies don't quite follow the same rules that the actual frequencies do.
Oh, I'm sure that's it. You're right.
Yeah, because with a Hardy-Weinberg, where you can do, the square root of P and Q, I think you're assuming that natural selection isn't playing a role. Here you're looking at fitness and like evolution.
You're right. Yeah, so that wouldn't work. Okay,
Awesome.
that's also
Great
good to
question
know.
though. Yeah,
That's also
really
good
good
to
question.
know. What else was I gonna say? Okay, I mean, I think that's it. I'm definitely very, very nervous about this exam.
Right. Well, yeah, I mean, I heard that or I think at least in last session, exam two was the highest scoring one, not by too much, but um all of these questions are probably going to be a tad harder than the ones on the exams, especially since you can't have a calculator on it.
Okay.
Yeah.
And then for like the essay questions for these modules, what are some of the likely options? I'm sure Dr. Holchik is going to talk about it as well, but based on you guys' experience.
That's a good question. Kelsey or Jeanette, I don't know if you guys remember what your essay questions were. I've only ever seen one before.
Um, so for the most part, the essay questions seem to be really similar to the activities.
Activities, okay.
Yeah, because I mean, she tries to ask questions on the exams that cover basically like all of the material, but
Hmm.
Mhm.
the activities is really difficult to ask like, multiple choice questions that would cover that kind of material. So that tends to be what she uses for the essays.
That's what I was guessing too, but good to know. Thank you.
Yeah. And she'll go over probably this afternoon, she'll go over kind of like an example of
Yep.
an essay question. Definitely pay attention to that because that's where she wants her head at.
Mhm.
Yes.
Sounds
Yeah.
good. Sounds good. Thank you so much. You guys
Yeah.
are always very, very helpful.
I'm glad that we could help.
All right, I'll see you
All right.
next time.
Bye. Have a
Thanks.
good one.